Okay, today we're going to take a look at proof and perpendicular lines. And the two types of proof that we're going to look at today are going to be a flow proof and a paragraph proof. A flow proof uses arrows to show the flow of a logical argument. Paragraph proofs are exactly as we talk about. Okay, basically you're writing sentences to fill in and prove how something is true. Okay, theorem 3.1 says if two lines intersect to form a linear pair of congruent angles, then our lines are perpendicular. Okay, and theorem 3.2 says if two sides of two adjacent acute angles are perpendicular, your angles are complementary. Okay, we're going to take a look at some examples with each of those as we go through the process tonight. And the last one, theorem 3.3, is the right angle congruence theorem, I believe. Okay, if two lines are perpendicular, they intersect to form four right angles. Okay, so when you have lines that are perpendicular, they're going to intersect to form four right angles. And we've talked about this at different points in times as we've already gone through the year with some of these properties. Okay, remember that if you happen to have a right angle marked, okay, for example, we've got this right angle marked right here, okay, with one of those angles, then all four of our angles are going to be right angles as well. So once you have one pair of angles congruent, then all four of them have to be congruent. Okay. We want to find our value for x. Okay, what we want to look at here, first of all, is identifying that these two angles here form vertical angles. Okay, so that means that this angle down here is 29 degrees. But what we also know is that this angle here is 90 degrees. So since this is 90, this is 90, this is 90, and so is this. So that means that this x and this 29 have to add up to give us 90 degrees. Okay, so when you have two angles that create a right angle, they are complementary. So we're going to subtract our 29 from both sides, and that's going to give x being the value of 61. Okay, and that is the theorem that talks about when you have two angles that create a right angle that are those two acute angles then have to be complementary. Okay, which I believe is theorem 3.2. Okay, this is theorem 3.1. Okay, you have a pair of congruent angles that create a linear pair. Okay, you know this angle here is 90 degrees. Well, so is this angle. So that means that you have that 3a minus 27 and 2b minus 14. But remember that both of those angles, or both of those lines, are going to end up being 90 degrees. So 3a minus 27 is going to be 90. And add our 27 to both sides. So 3a is going to equal 117. Okay, and we divide both sides by 3. We will find that our value for a is going to be 39. Now, similarly, we're going to work with the other angle as well, the 2b plus 14. And that 2b plus 14 is going to equal 90. Okay, so we're going to subtract 14 from both sides. So 2b is going to be 76. You divide 76 by 2. The value for b is 38. What I need you to remember, though, is that the reason that this works is that both of these angles, both here and here, are 90 degrees. Okay, and that's the only reason that that works is because both those angles are already 90 degrees. Any questions on those? Okay, now, what can we conclude about our labeled angles in this picture? Okay, which of the following cannot be true if angle 2 is 90? Alright, so we're going to fill in the fact that angle 2 down here is 90 degrees. Alright, what does that make angle 1? Okay, well if this is 90, then angle 1 up here has to be 90 also. Okay, maybe. Alright, now, that tells us which of the following must not be true. Well, angle 1 is a right angle, we're good on that. If angle 1 and 2 are both 90 degrees, you also know that they are perpendicular. Okay, the unlabeled angles. Well, if these two angles are both 90 degrees, so are these two angles over here. This is going to be 90, this is going to be 90. So the correct answer is letter D. Angle 1 and angle 2 are both 90 degrees, so it's impossible for them to be complementary. If each angle is 90 degrees, 90 plus 0 is what's 90. They would be supplementary, but certainly not complementary. Alright, given that L and M are perpendicular, we're going to prove that all four angles are right angles. Okay? So, We're going to write this in paragraph form. Okay, and this will be kind of an adventure with the way the board's working. Okay, now, by definition of perpendicular lines, and I'm going to allow you on this to use the upside down T for perpendicular. Okay. Definition for perpendicular lines, angle 1 is the right angle. Alright, now, we also know that angle 1 is congruent to angle 3 because they are vertical angles. So far you're good here, you're good here. Okay? Now, since we know that angle 1 and 2 are a linear pair, measure angle 1, plus measure angle 2 equals 180. Okay? Okay. Now, since angle 1 is a right angle, okay, we know that angle 1 has to equal what measure? 90 degrees. So we can substitute that 90-degree angle in for angle 1. So 90 plus the measure of angle 2 is going to equal 180. Okay? By subtraction, then the measure of angle 2 is going to equal 90. Making it a right angle. Making it a right angle. Since angle 2 and angle 4 are vertical, angle 4 is a right angle as well. You get all the angles, right angles. Now, as you can see, that took a lot of writing. Okay, it's like writing a gigantic paragraph that you'd have to do in English class. Okay, so one of the things that you need to know is that we're going to do a couple of these just so you've seen them, before, but it's not something that you're going to really be tested over to in a course test. And honestly, unless you go into college and go into math theory classes, it's not going to be something you're going to really work with a whole lot. Okay, so if you need to pause the presentation at this point to try to read the chicken scratch that's up here on the board, you can do that. But that's how a paragraph proof comes together. You're just continuing to write the reasons why and also what you're writing as well to go through your process of showing a proof. Now, the final way that we're going to look at this is to use a proof that has a flow chart. Okay, and this flow chart proof is kind of all over the place. Okay, but what I want to show is that AD is perpendicular to BC. Okay, I want to prove that DC and BC are perpendicular also. Okay, so all that stuff is given, and that's in our first set. Now, we know, because of the definition of perpendicular lines, that when you have two lines that are perpendicular, you have right angles. Okay, so our statement that we're going to fill in here in this first box is that angle B and angle C are right angles. Because that's what perpendicular lines do. They create a right angle. And then there is a theorem that will state this also for now because we haven't gotten to that. Okay, it's called a right angle congruence theorem. But what we're just going to use right now, because we haven't gotten to that yet, is the definition of a right angle. Because all right angles are 90 degrees, we know that if two angles have angle measures of 90 degrees, then those two angles have to be congruent as well. Okay, at this point we're going to pass out the papers for homework, which is worksheet 3.6.